You know the rules and the laws. Don't want to be illegal. You know me. All right. So 1-6 transformations. This is going to be a pretty basic homework assignment. I think it's 1 through whatever 30, 20 some odd. You can check the odds in the back of the book. And really, that's what it is. You're going to be reading the questions, maybe write the question down, but then you just answer it. You know, it's one of those. It's not a math day. It's recognizing what I'm going to show you today, which you learned last year. Okay, so the first column over here, I kind of broke this down separately. You could put it all together, but then it gets a little confusing to do that. Is the right, left, up, down shifts. I'm done. Write that down. That's function notation. This means everything, every function that you deal with gets affected the same way. All right, so if I have a number inserted on the inside of a function, plus or minus, that is a right or left shift. On the right-left shifts, I always tell my students, think opposites. So what does that mean? Look at this little blue in the corner. All right, hopefully you can see that. X squared is a parabola with a vertex of 0, 0. And then it was on, actually, your quiz that I just went through. When I put x plus 2, which way does that move? Great. I love when that keeps coming up. Don't show this message again. What does plus 2 do, class? Hey, show the internet that you're here. Plus 2 goes which way? Left 2. So that's why the vertex is at negative 2, comma. And then minus 1 on the outside of the squaring function, which way does that go? Same, so down 1. You expect minus to be down, and it is. So that's, you know, what I said last year. So that's how functions get affected there. Next thing that you know, let's go to the middle column. X-axis reflections. When you throw a negative in front of an x squared, it flips the parabola upside down. We know that. That happens for all functions. I throw a negative in front of the function itself, it flips it. But look at this one. And I don't want to highlight it, but I will circle it or square it. That is a negative inserted to the inside of a function. Now what that is, that might be new for you, because I know last year I kind of glanced, you know, maybe someone asked me in class and I just said it, but I kind of steered away from it. That is a y-axis reflection. And the best one that shows up in, real small here, if I could zoom in, fortunately that kind of jacks up my, program, the square root of x function. That is the picture of the square root of x function, the basic function that you're supposed to remember. That's inserting a negative on the inside. The square root of negative x, plugging in negative x for x if you will, but not really, just putting a negative on the inside of the function. What that does is reflects that square root function over the y-axis and makes it face left. And I can explain that because the domain's changed. You can't plug in 1 for this anymore because then that would be the square root of negative 1. What you can plug in, though, is negative 1 because that's the square root of negative 1. What's a negative 1? Answer the question. Square root of 1 is 1. So negative 1 comma 1 is now a new coordinate. So be aware of that. And then the last of the Algebra 2 things that we did last year was the dilation factor. When you throw a number in front of a function, that makes the graph do 2 things. How many people are a White Sox fan? Okay, stretch, stretch, stretch. Then what's the next thing he says? You can... You're not going to do it? You come on, who's going to... Nobody? You can put it... Someone's whispering over there. Put it on the board. Yes. What does he mean by stretch? What does he want that ball to do? He wants that ball to move away from home plate to get over the fence. You got it? Yes, that's true. I don't care if you don't like it. All right? So... So when A is a number bigger than 1, that is a vertical stretch. We can no longer use skinny and wide because not all graphs look skinnier or wider when they're stretched or shrunk. That's specific. So what does it mean vertically stretch? Stretch away from the x-axis. And then what if the number is between 0 and 1? That's a vertical shrink. That's like 1/2. 1/3, so on and so forth. I'm gross. Sorry, I just started the movie too. It's 95 degrees with 100% humidity in the classroom. Your poor son or daughter dealing with this. Anyway. Okay, so this is the book's representation of the same thing. Don't rewrite this. Okay? That's what we just said. But you know what? This is weird, the one that I have above there that I did not do. You better write this down. And it's strange. With the regular students, I kind of don't like teach this or maybe just show it real quick and try to avoid it. You guys, I'm not. You're going to have to know this. But do you know what? Okay, stop. All right, see how this notation is? It's f of x over c. I'm gonna compare these two. Because when I say a vertical stretch, you're stretching away from the x-axis. If you're stretching away from the x-axis, what are you doing with the y-axis? You're getting what? If you're stretching away from the x-axis, what are you doing with the y-axis? You're getting closer. So a vertical stretch is equal to a, look up here, horizontal what? Shrink. All right, and that's what's weird. You know, they're almost synonymous with each other. Because if you stretch away from the x-axis, you're actually stretching towards the y-axis. So a vertical stretch is similar to a horizontal shrink. And a vertical shrink is the same as a horizontal what? Stretch. It's all about a perspective thing. So that's why I kind of really don't like the horizontal shrinking and stretching thing. They kind of are similar, but mathematically something happens a little different. Look what I put up here. X squared. So the way it's plugged in is x over 2 squared. This is what I kind of want to get you to understand. That's supposed to be a horizontal stretch. Well, then it must be a vertical, say it, shrink. Well, look at what happens mathematically. X over 2 is 1/2 x, or that turns into x squared over 4, which is 1/4 x squared. And what does 1/4 out in front represent? A 1/4 in front represents a vertical shrink. So there you go. Lo and behold, a horizontal stretch turned into a vertical shrink. What? Shrink. All right. So the first two questions I have, I just shoved the notes at you, and you can look at it. Okay, so, and it's worded very strange in this book. Here's f of x. Just concentrate on this. Here's f of x. This is what I want you to do. I want you to vertically stretch this C1. I don't know why they're calling it 3 different things. They just want to be cryptic and all. Like, let's try to confuse the kids as much as possible. All right, but anyway. So a vertical stretch by a factor of 3 means multiplying by 3 on the outside of the function, which actually means 3 times x cubed minus 16x, and then you could distribute. There's your vertical stretch. Whereas a horizontal shrink by a factor of 1/2, this is the math that you do. F of x over 1/2. And of course, everyone knows x over 1/2 is the same thing as 2x, I hope. And then what you actually do is plug in 2x wherever there's an x. And then cube it. And then lo and behold, x cubed now has a what in front of it? Now what's in front of x cubed? An 8, which actually represents a vertical stretch. So horizontal shrink turned into a vertical stretch when you kind of look at it that way. Little different, but that's what's going on there. And I'll pause that for a second. Now what you better darn well get familiar with, like the back of your hand, is, I kind of limit it down to 9 of the 12. Although, you do have that logistic function that came up on yesterday's or 2 days ago's quiz. So that was kind of rough, but we did cover it. The greatest integer function, you should be aware of what it looks like. I do have it on this page, I think. But these are the ones you better know like the back of your hand. We did all these last year. Okay, x squared, x cubed, reciprocal function. I have the line function down there. So have your book out and get these known like the back of your hand and then know how to shift them. Don't take these down. You already have them. You have the book. You better get familiar with the exponential function, although we are going to hit that hard in Chapter 3 again. Know that square root function. Know an absolute value as of right now is a v, a linear absolute value situation. This one you better get familiar with. A logarithm function. know at least that a logarithm function has a vertical asymptote at x equals 0, and then it gets shifted if there are moves left, right, up, and down. So be aware of that. I circled the identity function because we're not really going to treat that with shifts. You know a line has a graph y equals mx plus b, at least an equation. So that one kind of stands alone. And then remember how the greatest integer. Those 9 you better get real familiar with, real fast. All right, because then what you're going to do with these things, intermittently and back and forth, don't write these questions down. You're going to analyze changes in this. I'm not even going to write these down. We're going to verbalize them. So this first graph, compared to y equals x squared, where does this go with the plus 5.2 on the outside? Where does it go? Up 5, done. What's number 4 do? Minus 3 on the inside. Right 3, so the new vertex would be 3, 0, over. What's the next one do? Down a hundo. 0, negative 100. What's the last one do? Left 50, down 279. Let's move on. Okay, we do have some tricksters here. You might want to write down 13. But number 10 is Mickey Mouse. That means easy if those that don't know that. I don't know. X minus 5 on the inside. Which way does this go? Right 5. And I threw the picture there. So knowing what this picture looks like and then graphing it real fast by moving it right 5. Over. But this one's a little trickster. A little sneaky. 3 minus x. Fumble. That's the second time today. What you got to do first is factor out a negative 1 and then rewrite that as x minus 3. Because actually this goes 3 to the right. And then what's this negative on the inside of the function do? Reflects it over the what? Y-axis. And then that is the picture you're going to see. There's a reflected square root function, move 3 to the right as well. Oh yeah. This is the kind of stuff you're going to have to do. Now this is like a kick in the, stomach. But did you know that this is actually the same thing as... Oh, I thought my pen stopped working. You were about to see some real immature behavior from a teacher if that happened. That's this. Huh? Huh? So that's a, a horizontal stretch or shrink. Shrink by a factor of a half. Or, don't you know that this is the same thing as 8x cubed? Huh? You could also tell me this is a vertical stretch by a factor of 8. Isn't that wild? Yes, Mr. Samuelus. And then this is called a what? A vertical shrink, because it's less than 1 by a factor of 0.3. So I figured I'd cover 14 because there's a couple different correct answers. All right, and then, I don't know. These are weird. They're just trying to be real cryptic and confusing. But describe how to transform F into G. Whoa. First of all, what's the vertex of this one? No time. We have 3 minutes. Right? What's the vertex of this one? And then what else? How is G of X different? It goes down. So how do I turn F into G? How far do I have to move F to get to G? I have to move 4 spaces which direction from F to G? 4 spaces left and then flip it vertically, I guess. Oh boy, there's some real sticklers in this math department. Me saying the word flip instead of the math word. Reflect over the x-axis. Look out, okay? So watch out if you're talking in the halls and another math teacher sees you. They may tackle you in the hall. It's reflect! Now I'm not going to graph all these. Okay? Here's the basic absolute value function. What's negative in front do? Reflect! What's the 2 do? Vertically stretch. What's the minus 3 do? And then you could do that. Actually, 2 represents the slope that you can use. 3 vertical stretch. Plus 5 does what? 5 left. What's the plus 4 do? Up 4. I think you can handle it, and I think I've covered everything I wanted to do. We were going to graph that, but we're not.